This is an Algebra 1 review of properties of exponents for the Algebra 2 class. So in preparation to work with exponents, we need to go back over something you probably haven't talked about in a while. One of the things we did in Algebra 1 was we learned how to do this problem. X to the 6th times x to the 3rd. Now, your teacher probably told you the property, but the question is, how do you get there? Well, remember what an exponent means. X to the 6th means write x 6 times. And then x to the 3rd means write x 3 times. Well, when I write out 6 x's and 3 x's, I have a total of 9 x's. So the property of multiplying exponents with the same base was a to the m times a to the n is equal to a to the m plus n. Now, this property is often mixed up with the next one we're going to talk about. What if I wanted to do x to the 6th to the 3rd? If I do this the long way, to show you where the answer comes from, this says write x to the 6th 3 times. So I would do that. And then each of those x to the 6th is writing out x 6 times. So 1, 2, 3, 4, 5, 6, and do it again. 1, 2, 3, 4, 5, 6, and then I'm going to do it again. 1, 2, 3, 4, 5, 6. Well, how many x's did I just write out? It was 18. The easier way to get to it is this is the multiplication property on exponents. So when you have an exponential term being raised to another power, you can simplify it by multiplying the exponents. Now let's talk about this property. I want to raise the quantity x times y to the 3rd power. Well, first of all, that says to multiply xy 3 times. But even though I didn't put the dot between the x and the y, there really is a dot there. Make some little dots. Now, the nice thing about multiplication is that the order in which we do it doesn't matter. That's called the commutative property. So if I wanted to rewrite this so the x's were written first and then the y's, this would be the same multiplication problem. Well, don't I have 3 x's and 3 y's? This is the distributive property of exponents. If you have factors being multiplied inside a set of parentheses, you can distribute that exponent to each factor in the parentheses. This property not only works for multiplication, but it also works for division. So if I do x over y to the 3rd, which is the same thing as x over y times x over y times x over y, if you remember that when you multiply together fractions, you multiply the numerators and you multiply the denominators. So there are 3 x's on top and 3 on the bottom. So here's the property. Now let's talk about division of exponential terms. We talked about multiplication, now let's do some division. So, x to the 6th over x to the 3rd. That says there are 6 x's on top, 1, 2, 3, 4, 5, 6, and there are 3 x's on the bottom. Well, maybe you remember from learning fractions that we could do this thing called canceling. If you have the same factor in the numerator and denominator, you can cancel it. Well, I can cancel 3 from the top and bottom, but then I'm left with 3 on top, so it turns out that the answer is x to the 3rd. Because the property says if you divide 2 exponential terms with the same base, you can simplify them by subtracting the exponents. Well, let's see what happens when I flip those. Instead, let's see what happens when I do x to the 3rd over x to the 6th. I'm going to attack the problem the same way. There are 3 x's on top and 6 on the bottom. And then I'm going to go cancel. And when I'm done canceling, I'm left with 3 x's on the bottom, But the question is, what am I left with on top? One of the things we tend to forget is that these variables have a coefficient, and that coefficient is 1. So there's still a 1 on top, not a 0. Students often mistake that when there's nothing left, nothing means 0, but in this case it's 1. Now, what if I had used the property on the page before? What if instead I had said, okay, well, I'm going to do x to the 3 minus 6. I would have gotten negative 3. Well, it turns out that's the same thing as 1 over x to the third, because either way I do the problem, these answers must be equal. So we have a property that says if you have an exponential term raised to a negative exponent, you make its reciprocal. And when you do that, the exponent becomes positive. The way that I explain it to Algebra 1 students is I tell them if you have a negative exponent in the numerator of a fraction, bump it to the denominator, and the exponential term becomes positive. So the converse must be true. If I have a negative exponent in the denominator of a fraction, I can get rid of it by moving it to the numerator. And one of the things we're going to do is we're going to always get rid of negative exponents. There's one more exponential property I want to talk about. What happens if I do this problem? Now, let's start with the fact that we already know the property. The property of exponents says that I'm going to do x to the 6 minus 6. Well, 6 minus 6 is 0. Well, what is x to the 0? Well, let's go back to this. What happens if I write 6x's on top and 6x's here in the denominator? And then I do my canceling. But we said just a moment ago, you need to remember that there really is a coefficient, isn't there? And that coefficient is 1. So when everything cancels, you're not left with 0. You're left with 1. So x to the 0 power must be 1. So we have a property that says anything to the 0 power is 1. And the reason that happens is, think back when you learned elementary division. You know that 6 divided by 6 is 1. That's because anything divided by itself is 1. If I make this 6x divided by 6x, it's still 1. And my favorite, if I make it rabbit divided by rabbit, it's 1. Because anytime you have the same thing in the numerator and denominator, it will become 1.